Good morning, good afternoon, and good evening to everyone watching this video. So, welcome back. In the last video of permutation and combination, we built the foundation of counting using FPC, fundamental principle of counting, and factorials. So, if you haven't watched that video yet, so please watch that video before watching this one. Alright, so moving on. Today, we are going to learn about permutations. This is where students usually feel that permutation and combination is hard because they've memorized formulas instead of thinking. They just think कि permutation है तो बस NPR लगा दो and that's it. But no, it's not just about formula. You need to think what are the possible ways and how could you calculate it. So in today's video, these are the topics we are going to cover. First, we'll have a quick recap of video 1. Then we are going to talk about what are permutations. Then we are going to talk about permutations without repetition and with repetition too. We'll see for concept of without repetition, then we'll see the formula and see some simple examples. And for with repetitions, we also see concept, formula, and some examples related to passwords, digits, and alphabets. Then we are going to see arrangement of letters which are all distinct, and then permutation with repeated letters. Alright, so these are the topics we are going to cover today. But before that, let's have a small recap of our last video. Alright, so here's where we ended our first video. This is the summary. So we'll just recap this and then move on. First, we learned about the fundamental principle of counting, where m into n is equal to total ways, where m and n are independent tasks. Then we learned about what are independent events, the same m and n example. Then we saw a tree diagram with example of a coin and the rolling of a dice for better understanding of FPC. Then we saw factorials, in which we learned that what are factorials and how are they used in PNC. And these using of factorials then led us to basic permutation. Alright, so now moving on. Alright, moving on. As I said, I was going to explain why 0 factorial is equal to 1 in my last video. So let's talk about this and then we'll start with permutation. So as we know that factorials like n factorial can be written as n into n minus 1 factorial, right? As we can see that 5 factorial is equal to 4 factorial into 5, which gives us 5 factorial. Alright, we all know this. So similarly, as we move down from any number and we reach 1 factorial, then what is 1 factorial? It is 1 into factorial of 0, because 1 minus 1 is equal to 0. Now we know 1 factorial is equal to 1. Then we are left with 0 factorial. So 0 factorial, now moving this 1 here, gives us 0 factorial as also 1, because 1 divided by 1 is simply 1. Hence 0 factorial is equal to 1. Yes, this was the explanation of why 0 factorial is equal to 1. Now what does permutation mean? Permutation is basically arrangement. Now what does it mean? Basically, if order matters, it's a permutation. Now let's see an example of where does an order matters, so it's counted as permutation. Now let's take an example. We can say if ABC, then place them in order to get different arrangements. Now ABC can be written as ACB or BAC and other examples also. Alright. Now, but we see ABC is not equal to ACB, right? Because we are told to keep them in an arrangement. So these are different arrangement than this. But if we talk about combination, then these are the same because they contain the same elements A, B and C. So what is permutation? Permutation is basically combination plus arrangement. So we form a combination of elements and arrange them in particular ways to get a permutation. Now these three can be, as I said, can be arranged as BAC and ACB, and all these permutations will give us a different answer. Hence, this is permutation. Arranging of different elements or same elements, we can arrange same elements too. We'll see forward in our video how can we arrange same elements. For example, there's school. Now school has two same letters. How can we permute them? We'll see this in a few minutes. Alright. Now let's talk about permutation without repetition. So when there's no repetition, we have a formula for permutation which is this. Uh, this is the way to write permutation, NPR, and for combination it's NCR. We're not going to talk about combination in this video, but yeah, just know that NCR and NPR are the representative ways to represent NPR, permutation and combination. All right. So this is an important formula. I'll write it properly. So this is a formula. Now what is N and what is R? So N here is the total number of elements available. Now let's take as example we have A, B, C and D, and we only need to arrange three letters. Arrange three letters out of four. So like I need arrangement like ABC, or there could be an arrangement like BCD and other three elements together. So here n is the total number of elements. So n, for example, in this example n is equal to 4 and r is the required number of elements. Now we require three elements to be arranged, then r here is equal to 3. Now let's see example and solve an example using this formula. Let's take the same example of ABCD and we need to arrange three letters. So now how many ways can we arrange them? So how let's take the example ki what are the arrangements like A, B, C. This could be one arrangement. Then there could be B, C, D, A, B, D and other arrangements. Now we cannot just calculate, we cannot just count every possible way. So now let's use our formula which we learned. So here we can use NPR, where NPR is equal to n minus r factorial. Alright, now as I said, n is the total number of elements. So n here is 4 and the required number of elements to form the arrangement is 3. So r here is 3. Now we simply solve. So it goes 4 factorial divided by 4 minus 3 factorial. All right. Now uh, solving this gives us 4 factorial divided by 1 factorial. 1 factorial is 1, so we can neglect it, and the answer is 24 because 4 factorial is equal to 24. So this is our final answer to this question. So this is how we use the formula of NPR. Now this was without repetition. So with repetition, there's a difference in our formula. So let's talk about it. Now, if in a question the repetition is allowed, then the total number of ways is basically n to the power n. Now, how is it n to the power, n to the power r? The total ways is n to the power r. Now, how is it n to the power r? So let's take the same method to solve the question which we used in our previous video, where we had three blank spaces, and let's take we need to fill them with numbers from 0 to 9. Now from 0 to 9 we have 10 choices, and the numbers are allowed to repeat. Then here I have 10 choices, and let's keep filling a number. For example, now I have filled example here 7. Now here repetition is allowed, so there's no condition that we cannot put the same number, for example 7 here, so we can put 7 here too. So like that we also have 10 choices here, and similarly we have 10 choices here too, and we can put any number like 3, 4 example. All right, so this is one arrangement, one permutation, and these are the total number of ways. So we can write is basically 10 to the power 3. Now notice we need three letters to be arranged, and there were 10 total elements. So n here becomes 10 and r becomes 3, right? So yes, when repetition is allowed, total ways to calculate the arrangement is n to the power r. Now repetition is way easier than without repetition, because without repetition there was a big formula, and with repetition there's a very small and easy formula. We just need to solve this n to the power r, and that's it. So let's take an example. Now for example, I have 3 digits to be filled in these places, and the numbers as usually are single digit for passwords. So I have 10 options here, 10 options here, 10 options here, because I can put any number, like example 993, or I can put another number 774, 663. Many arrangements I have. So now this 10 to the power 3 is equal to 1000, right? Now let's solve this with the formula. The formula is very easy, that total ways is equal to n to the power r, where n to the power r filled with values with the n here is 10 and r here is 3, because we need 3 elements to be arranged out of 10 elements. This is also 1000. Hence this is the use of formula here. So our final answer is 1000 from both ways. Alright, it's this simple. Now moving on to a small topic, which is word arrangements. Word arrangements. Now there are two ways of arranging words. One where the letters are repeated, and another where all the letters are distinct. Now let's see about the distinct ones first. So arranging words where all the letters are distinct. So the total number of ways of arranging them is equal to n factorial. Yes, it's that simple. Now example, we had a word like help. A basic very simple word with 4 letters, and none of them are repeating. So now if we had to arrange them in some ways, then we can use n factorial. Now let's take another easier example so that we can calculate each arrangement by ourselves. Let's take a very simple word, cat. Now let's solve them by two ways. First we're going to actually calculate the total number of arrangements, then we'll use the formula. Now for cat, this is one arrangement, the first arrangement. For second arrangement, CTA,
We have replaced the A by T and T by A. Then we ATC, ACT, TAC and TCA. I've got all the possible arrangements of these three letters. So counting it gives us the value 6. So we got 6 arrangements in total by actually counting it. Now let's use the formula. So the formula says that total number of arrangements is equal to n factorial when n factorial is the total number of letters. Now for the example of cat, we have 3 letters, 3 distinct letters. Hence the total is equal to 3 factorial, which is equal to 3 into 2 and 6, right? Now note n is the distinct letters present in a word. Now let's take an example of school. So we cannot calculate the number of ways to arrange the letters of school correctly by using this formula. So we have a different formula for that. But before that, we need to know that ways to calculate distinct letters, total ways to calculate arrangements of distinct letters in a word are n factorial. Now, the same example of help. Now, if we solve help, so we get total is equal to 4 factorial, which is equal to 24. Now, if I would have actually calculated them, then I would also have gotten 4, but 24. But actually calculating 24 arrangements is way harder than 6. And why should we calculate when we have a simpler formula to calculate them? All right. So this was about distinct word arrangements, distinct letters. Now let's talk about repeated letters in a word. Now for repeated letters in a word, the formula is total is equal to n factorial by p factorial, p2 factorial and so on. Now what is n here and what is p, p1, p1, p2 and p3, p4, etc. Now the same example of school, as we have talked that we cannot use the distinct letter formula for repeated letters. Now why can't we use this? So for better understanding, let's take this. There are two O's which are repeated. Now if I write it the O's with different color for better understanding, a letter like this. The fonts are different, but let's just take it like this. And other way to write school, where I just shuffle these two. So the red O comes here and the green O comes here. Now these two are the arrangements which would have been counted by n factorials because it would have counted two O's as distinct. But obviously these two are the same. If we keep this O here or this O there, that's the same thing, right? So that's why we cannot use the same formula of distinct letters for repeated letters. So we have a formula here which is total ways to arrange the letters are n factorial by p1, p1 factorial, p2 factorial. Now what is n? N is the total number of letters in a word. So like school has 3 and 6. School has 6 letters. So n here would have been 6. And P1, P2. Now what are P1, P2? P1, P2 are the letters repeated and how many times are they repeated. So P1 is basically, now we only have one letter repeating. So we have P1 and how many times are they repeating, which is twice. Hence the value of P1 is equal to 2. Now if we had a letter with two letters repeating or a letter repeating thrice, let's take the same example of the word repeated. Now notice E here is repeated 3 times, right? So here there would be P1 with value 3. Hence it would be divided. Now there are 6, 7, 8.
So it would have been 8 divided by 3 factorial for this. And let's take another word, arrangement. It's a big word, but notice now there are 3 words repeating twice. Like these are 1, this is 2, and this is 3. Oh, actually 4 letters. N is also repeating twice. Now, to calculate this, the total would have been N divided by, where P1 is equal to 2 because A is repeated twice. P2 would be 2 because it is all R is repeated twice, and P3 would be 2, and uh, 4 would also be 2 because 4 letters are repeated twice. Hence there would be 4 2 factorials. It might be a little confusing right now, but when we'll solve questions, it would be easy to understand by that time. All right. So this is the formula. Now, before moving on, let's recap this part again. So we here know that we have two extra words where we only need one. We only need one arrangement of school like this, right? But there are two. So we are basically dividing it by 2 factorial, the number of ways. Now if we had 3, then we would have 6 extra letters which would have been the same, right? That's why we divide by 2 factorial, because there's one letter repeating twice. Now if there were 2 letters repeating twice, then we would have 2 numbers and 2 factorial 2 times. If there was one number repeating twice and one number repeating thrice, then we would have been divided n factorial by 2 factorial and 3 factorial. Now we'll see a example question in which there are different letters repeating different times, so it would be easier for you to understand it. But till now, just remember the formula is this. Now let's solve the question of how many ways can we write school, how many ways can we arrange the letters present in school. Now solving it, the total value here is equal to n factorial divided by, there's only one number repeating twice, hence 2 factorial. Now what is n factorial? N here is the total number of letters present in the word. I have said it many times before. So it's 6 here. So it's 6 factorial divided by 2 factorial. Now notice I can expand this 6 factorial here. I can expand the 6 factorial and write it as 5 into 4 into 3 into 2 factorial, right? 6 into 5 into 4 into 3 into 2 factorial. We have expanded it till 2 factorial, and there's 2 factorial. So this can be cancelled out, and our answer is 6 into 5 into 4 into 3. Now calculating this would give us 360. Hence our answer is 360. Now actually calculating the number of ways is very hard here, because we cannot just keep counting till 360. I have taken the example of cat, which was easy because it had same letters. Now for better understand cat, because it had only has 3 letters, so it had only 6 arrangements, which was easy to calculate, but 360 is very hard. But for better understanding, I'll take a word with no meaning, but where a word with no meaning and a letter is repeated twice. Now let's take A, Now this word makes no sense, it has no meaning in English, but we'll see for our better understanding. Now using the same formula, first we'll solve by using the formula, then we'll solve by actually arranging them. The formula says it's n factorial divided by p factorial, because there's only one number repeated, so only one p, where n is equal to 3 factorial and p is equal to 2 factorial, because a is repeated twice. Now what is this? It is 3 into 2 factorial divided by 2 factorial, where 2 factorials can be cancelled out, and the answer is 3. Now let's actually calculate it for verification. Now I can write it firstly as arranged like this, Then we can arrange it like this, and then we can arrange it like this. Now there's no other way to arrange them. We cannot replace this a and keep this a here, because that's basically the same thing. So as you can see, we had three arrangements here and and three arrangement here. All right. All right, guys. So now let's solve some JEE level question. Easy JEE mains level question of they are very easy. So let's solve them. So till now we have completed permutations. So we'll only solve the questions which include only permutation and no combination. Well, permutation is basically combination plus arrangement, but yeah, that's a different topic. So for our first question, all right. So our first JEE level question says total permutation of Mississippi. Now it's a very easy formula based question. There is no thinking part here. We just need to apply the formula. So let's solve this question. Now for solution, we know the formula to arranging words with repeated letters are total ways is equal to n factorial divided by p factorial, p2 factorial, and till the number of letters are repeated. Now for the example of for the question Mississippi, we see 1 2 3 4 and 11 letters. You can count it. I've counted it. It's 11 letters. All right. So now applying the formula for total ways, we have n factorial, which is 11 factorial, divided by here p. Now we have three letters which are repeated, so we will have p1, p2 and p3. Now for example p1, so let's take I for p1, and I is repeated four times, as you can see. So p1 is equal to 4, and for p2 let's take s is also repeated four times, and for p3 p, which is repeated twice. All right. So now putting the values, we have 4 factorial into 4 factorial into 2 factorial. Now this question is easy because it only requires to put values in the formula, but the hard part here is the calculation. Now we need to divide 11 factorial by this. So first we can expand 11, so we can write it as 11 into 10 all the way to 4 factorial, and divide by 4 factorial here, 4 factorial also two times, and 2 factorial. Now 1 4 factorial and 1 4 factorial can be cancelled. Now writing all the numbers, now we have 11 into 10. We have this where we have expanded all the factorials. Now it's simply cancelling out. We can cancel this 2 and this 4 by 8, this 3 and this 2 by 6. So what we are left with is 11 into 10 into 9 into 7 into 5. Now you can calculate this and get the answer. I'll also calculate it. So after calculating, the final answer is a big number, which is 34,650. Yes, this is our final answer. See, this was a JEE level question where the only hard part was just calculating, was just multiplication. So it was this easy. It was only a JEE main level question. But yeah, in our future videos, we are going to solve JEE advanced and main level questions, which would be very tough, and we would be seeing different types of question like restriction based questions, which is very fun to do because you cannot just use formulas there, and you need to actually think, and there's more than one way to calculate those answers. So that would be very interesting to solve, which we would solve in our future videos. So that is it for today. Now let's move to our summary and take a recap of our video. Now for our summary, we learned about permutation, what is permutation, and learned permutation with and without repetition. I'll write repetition here in short. Next, we learned about word arrangements, again with and without repetition, and then we solved some JE level questions. It was only one JE level question, but yeah. So, this was it for today. Now, in our future video, we are going to learn either about combination or we'll solve some JE advanced level questions regarding permutation only. So, that is it for today, guys. And I have a simple question for you to solve, and you can comment the answer. So the question here is, all right. So here is the homework question. The question says, how many five letter words, how many five letter words can be formed from the word banana? So the word banana has six letters, and you need to form only five letter words. So you can use the NPR formula and you can solve it. So that was the hint. Try solving this question and comment the answer. In our next video, we'll solve this question and move on to our future topics. So that is it for today, guys. Thank you for watching.